Hello, you're welcome to my math friend, your favorite math educational channel. I have a great news and package for my dear junior high school students. Okay, great. Now, lesson is on the surface area and volume of solid figures. This is a challenge for a lot of students. Why is it a challenge? They find it difficult to understand the key terms related to figures. Okay, so we'll be comparing plain and solid figures in certain instances. Very well. Before we continue, I want you to like, comment, okay, and then hit the subscription button if you've not, and then share for more of this educative videos and for others to come and see the amazing work we are doing here. Great. Let's continue. Now, these key terms will help you to understand the subject of solid figures, plain figures, calculating their areas, their volumes. It will help you to appreciate the topic very well. Math is interesting if you understand. Let me help you to understand. Let's go. Great. Now, the first key term over there is plain. Plain. You have plain and solid. Now, we are going to use these figures to explain. Look at the figures down here and those here. Now, these ones, what figures? There's a square, there's a triangle, there's a kite, and others. When we say plane, just like the name connotes, plane means a flat object. So in other words, the 2D or two-dimensional objects, two-dimensional. So it doesn't have other dimensions attached to it. It's flat. So you have normally the length and the breadth, very, very flat objects. So you can't put anything in it. It's flat like a paper. You get it very well. So these are the plain figures. Then the solid ones are the ones on the right over here. So one, two, three, and more are solid. Solid in the sense that you see it has weight. It can contain objects. It could be liquids or substances or anything. You can put in milk. You can put in um, tomatoes. You can put in a lot of substances into it. So they are solid. So that is the little difference, basically. Now, the third one says cross section. We're going to focus on the solid figures over here. Look at the first one, just like the name says, cross. Which part? This is a prism. This is a prism. Okay. Now, a prism has, just a recap, it's a solid figure with a uniform cross section. Okay, so we'll come to that later on. Now, what is the cross section? I'm gonna say, what's this cross section? This huge term. Just like this name says, which part has been crossed? You have a lot of sections. One, two, three. So you have the back section here and then here. This side has been crossed. So this section has been crossed. So it's a cross section. That's in simple terms. You get it. Now, this side that has been crossed has its opposite side looks the same. So it's the same. It's uniform. It's one. So that was what we say, a uniform cross section. Very good. Okay, this example, this is a cylinder. It's like specifically a pipe. Now it also has a cross section. Very good. Okay, so you see that this cylinder also is solid. You see the hole here means that it can be filled with liquid or any substance. Very good. Well. Okay, so these are examples of solid figures, and then the cross with those which have cross sections. Okay, good. Now the other terms, let's look at the length, the breadth, the height. Okay, so looking at this very figure, this is a cuboid. You see that it is not flat like a rectangle. It has dimensions to it. Okay, so so you see that it can be filled with other items like tomatoes, anything, name it. Okay, cubes and all that. Very well. So the length has to do with the horizontal aspect. This side, there's the length, and this is the breadth. So it has length, one length, this length, this another length, this another length. The breadth, this side, one breadth, one breadth, one breadth, then one breadth. The height has to do with the vertical aspect. So there's the height, the height. When we take a wall, for instance, you can measure the height of the wall, the height of the table, height of any object, looking at the vertical aspect. So the extent the extent at which the object reaches, that's the height. Very well. The next one is the volume. Volume has to do with, you see that, let's use the cuboid for instance. Okay, Now, the cuboid over there is as a solid figure. It can contain objects, like we said. Good. Now, it means that it has the capacity or the ability to hold certain objects. Okay, so we want to measure its ability to hold it. So if you are filling it with tomatoes, cubes, or anything, water, what will be it could represent a water tank. We have rectangular water tanks. Okay, so what is the um, what will be the weight of the water? Very good. The weight of the cubes, the weight of whatever it is that is going to contain. So that's what we mean by the volume over there. Okay. Now, the other term is the surface area. So we have curved and surface. Curved and curved and curved and straight. Curved and straight surface. Let's look at the difference. Let's use these two figures, the prism and the so this one is a triangular prism because of the shape of the cross section. It's triangular. Okay. Now let's look at these two figures. When you say the surface, this is the surface. This has to do with the surface, the side, the surface, the surface, the surface, the surface, the surface, the surface. So the point is, when you look at these surfaces, are they curved or are they straight? You could see that the surfaces are just straight. The edges of the surfaces are straight. So we see these are straight surfaces. Now, when we look at this one, this surface, top here and then beneath it, what is the edges of the surface? When you look at a cylinder, for instance, you see that the cylinder has curved, the sides, the edges are curved. Very good. So this is a curved cylinder, has a curved surface. This one's a straight surface, straight surface. You see the difference very well. So when you talk about the area, whether the straight surface area or the curved surface area, the area is talking about the space that the object covers. Okay, very well. So I want to measure the area of the cylinder, the space, the surface area, the area that the surface covers. Okay, that's the area it covers. So this is an area. The board over here is on this area. So when we want to measure, let's say, the very space that the cylinder, okay, covers. Very well, the very space that the cylinder, so there's this space that the cylinder has covered, the surface space. That's what we mean by surface area. Area that the surface is covering. I hope you are following very well. Great. Now let's move on. The last part is interior and exterior. When we say interior, has to do with inside. Exterior has to do with outside. So interior is inside, just like the name means. Exterior, outside. Very well. There are a lot of terms, but these ones I feel a basic one and very key, important for you to note. Good. Follow us for solved examples, like we said, on the solid figures. Now, the next lesson, we are going to look at solved examples on um, on the cuboid. So pick a cuboid and solve one example, finding its area and its volume. Very well. I want you to really follow, hit the subscription button and share for the next video. Great. If you've been educated and blessed by this video, I want you to comment there and then follow. You can leave your questions as well. Great. This is my math friend. Indeed, your math friend. Stay safe. Bye.